everyone, welcome back to live stream session with Team Axiom. Today we have an exciting topic on container technologies. As you all know, in the development, we'll divide these all the phases into the development server, testing server, and the production server, where we can get the result outcome of the live application. Now, in this all the scenario, as we all need to follow the agile way of development, where every module need to be tested live. The development, the updates, the objective of the sprints need to be achieved module wise. So all the phases we need to perform within that sprint only. So it will become very tedious sometimes to do the continuous updates and deploy it onto the server and then test. At the same time, if the team is divided and the tedious part is of merging the updated code and then deploy and then test, and then if there are any bugs or if there are any issues with the acceptance criteria as defined, then again we need to rerun and redevelop and debug it. So to avoid these all the discuss issues, if we have an environment where all the distributed developers, right, can able to create their own container where they can develop and they can test the application there and there only locally, how it will be viewed and how the outcome will be achieved onto the production server. So means like same in the developmental server, in the testing server, and in the production server, it has to be, the outcome has to be viewed, outcome has to be achieved equally. As the final deployment is going to happen on the cloud, so every time merging deployment is a tedious task, and then only we'll get the results. So here comes the role of a container technologies, where every individual can create their own container. They can able to create an image of the application and able to simulate the outcome on the cloud on their local system only. So the technologies like Docker, Kubernetes, this kind of technologies are used, with the help of which we can create a container for us, able to test and able to view the outcome of the entire applications, and then if it matches to the like acceptance criteria, if everything looks good, then we can further go for the deployment on the developmental server, testing server, or the production server, whichever it may be. So to develop that environment locally, where we can test the entire features of the application, this is what exactly the motive behind understanding the container technologies. Today, with the Team Axiom, we are planning to explore these all, how we can develop, how we can develop that container over there, how we can test it, how we can produce the image, so that every individual, whatever the part you are performing, whether you are working on the front end, whether you are working on the APIs, whether you are performing a quality analysis or any other role, you can test the applications there and there only using container, and then further you can deploy it onto the server. It's a lightweight, so the troublesome and the time we are taking for merging all the updates and then deploy to the server, that will be reduced, and only the expected outcome, accepted results only can be deployed onto the cloud. This is what actually the motive behind the container technologies. I'll hand over this session now to the Team Axiom so that they can give us the better guidelines on all these container technologies and practically how we can able to perform it and get the objectives of the container technology. That will be that is the agenda behind these sessions. Over to Team Axiom.
Technologies, a game changer in how we build, deploy, and run software. Our topic is container technologies, revolutionizing software deployment. Get ready to see how these powerful tools are transforming the software landscape. These are the agendas which we are going to cover in an amazing session. Why the need of containers? What are the containers? Where are containers used? How containerization in action? Advantages of containerization. Disadvantages of containerization. Container orchestration. Let's begin our journey into the world of containers. Think back to the old days of software deployment. Imagine setting up a web application on a server. You would have to install the operating system dependencies, configure the environment. It was often a long, complex, and error prone process. And what if you wanted to run that same application on a different server? You would have to repeat the entire process, hoping everything worked the same way. This is where the problems of deployment complexity and inconsistent environments come in. Imagine trying to set up the same application on your laptop, a test server and a production server. Each environment might have different versions of software libraries, different operating system configurations, and different dependencies. This inconsistency often led to the infamous phrase, "It works on my machine." Another issue was resource inefficiency. With traditional virtual machines, each virtual machine reserves a fixed amount of resources, even if not using them all. This wastes valuable resources. Deployment cycles were also slow, taking days or even weeks to get a new application or update into production. Finally, scaling applications was a challenge. If your application suddenly experienced a surge in traffic, it was difficult to quickly add more resources to handle the load. Containers address all of these problems. So, we have seen the challenges. Now, let's see how containers provide a solution. So, what exactly are containers? Think of them as lightweight packages that contain everything an application needs to run: code, runtime system tools, system libraries, settings. Unlike virtual machines, which emulate an entire operating system, containers share the host operating system's kernel. This makes them incredibly lightweight and fast. Imagine a large cargo ship. The ship itself is like the host operating system's kernel. The containers on the ship are like our application containers. They are isolated from each other. So, what happens in one container doesn't affect the others, but they all share the ship's resources. This is what we mean by shared kernel. We build containers from images which are like blueprints. These images are built in layers, making updates and sharing very efficient. Docker is the most popular container runtime, the engine that creates and runs containers. Now that we know what containers are, let's see where they are used. Containers have become essential in many areas of software development and deployment. A prime example is microservices architecture, where applications are broken down into small, independent services. Containers are perfect for deploying and scaling these microservices. They are also crucial for cloud native applications, which are designed to run in cloud environments. In DevOps pipelines, containers enable continuous integration and continuous delivery, allowing for faster and more reliable releases. They are also valuable in hybrid cloud environments where applications run across multiple cloud providers and on premises data centers. Even at the edge, for example, in IoT devices, containers are used for running applications closer to the data source, reducing latency. Finally, containers help modernize legacy applications by packaging them into portable units. Now, for for the exciting part, let's see containers in action with a live demonstration. Alright everyone, let's dive into the fascinating world of containers. Imagine you are packing for a trip. You have a suitcase and you carefully organize everything you need. Clothes, shoes, toiletries. So it's all in one place. Easy to carry, right? That's what containers do for software. In simple terms, containers package up everything an application needs to run, its code, libraries, and even settings into one neat, portable bundles. It's like creating a mini environment that works the same, no matter where it's placed. Here's the magic. Containers are lightweight and use the host system's operating system. Unlike virtual machines that need a separate operating system for every application. This makes them super fast, efficient, and easy to manage. Now, why is this important? Let's say a developer creates an application on their laptop. With containers, they can be sure it will work exactly the same when it's deployed on a server, in the cloud, or anywhere else. Excited to see this in action. Stick around because up next, our team will showcase how Docker, one of the most popular container platforms, brings this concept to life. It's going to be an engaging and hands on demonstration, so gear up for an exciting journey into the world of containers. That was a quick look at containerization. Up next, my teammate will dive into the benefits of container technologies and much more. Stay tuned as we explore the advantages, challenges, and other exciting insights.
Containers offer numerous advantages. Portability is a major one because they contain everything an application needs. Containers can run consistently on any platform that supports the container runtime. This solves the work on my machine problem. Scalability is another key benefit. You can easily scale your application by running multiple instances of a container. They are also incredibly resource efficient, using far fewer resources than virtual machines. Deployment is much faster with containers, allowing for quicker releases and updates. They offer excellent consistency across different environments, and they provide strong isolation between applications. Finally, they enable microservice architecture, which improve application development and maintenance. With all these advantages, there are also some considerations. While containers are powerful, there are some challenges to consider. Security is crucial. Image vulnerabilities can pose a risk, so it's important to use trusted images and regularly scan for vulnerabilities. Orchestrating many containers can become complex, especially in large scale deployment. Managing persistent storage for containers requires careful planning, monitoring, and logging are also important to track the health and performance of your containers. Finally, there can be compatibility issue related to kernel dependencies, although this is becoming less of a concern with modern container runtime. Let's briefly touch on how we manage many containers at once. When dealing with many containers, especially in production environments, we need tools to manage them. There is where container orchestration comes in. Kubernetes is the leading orchestration platform. Other tools like Docker Swarm are also available. These tools handle container scheduling, service discovery, load balancing, auto scaling, and high availability, making it much easier to manage complex containerized applications. Let's wrap up with the look at the future. Container technology continues to evolve rapidly. We are seeing the rise of serverless containers, which abstract away even more of the infrastructure management. WebAssembly is emerging as a promising technology for running containers in even more diverse environments, including web browser. Security enhancements are constantly being developed to address the evolving threat landscape, and containers are playing a key role in the expansion of the edge computing. The future of containerization is bright. Now, I would be happy to answer any question you have. Thank you for your time. Now, the floor is open for the questions. As discussed earlier, my team members are now ready to take over and demonstrate the installation process of Docker. But that's not all. They will also show you how container technology work in action. So, sit back, stay engaged, and get ready to see the magic of containers unfold right before your eyes.
I am here to show the installation process of Docker. First, open the Chrome browser and search the Docker. Here we see the first official website of Docker. Click on it. Uh, Here we see the download Docker desktop. We are downloading for Windows AMD 64. Click on it. Here we see the download has been start. Uh, as I already downloaded, we will see in command prompt the Docker is successfully installed or not. So we will check on it on command prompt and click run as administrator. Click on S. Firstly, we have to check the WSL is installed or not, because WSL is necessary to run the Docker file, and WSL stand for Windows Subsystem for Linux, and is a feature that allows to run the Linux environment on Windows without needing a virtual machine. First, we will check the WSL is installed or not. type WSL hyphen hyphen version. Here we see the WSL version is successfully installed in our computer. We will also check the Docker container is successfully downloaded or not. Type Docker and hyphen hyphen version. Oh, here we see the Docker version we are using, that is 27.3.1. We have successfully installed the WSL and Docker in our computer. Uh, Open the file manager. Here we see the Linux in our computer is successfully installed to run the Docker file. We will open the Docker application in our computer. Click on it. Uh, Here is the dashboard of the Docker desktop. Uh, or Docker desktop, and this is a navigation sidebar panel. In containers, our containers are basically a running instance of the images. When we create a Docker file, uh, here the containers is created in the container section. In images, the Docker images is nothing but the templates of the project. We can also say the blueprint of the project, that is code, dependencies, and libraries and configuration file in Docker images. In volume section, here the Docker file is if the Docker file is deleted or removed at running instance or stop, we can retrieve our data from the Docker volumes. In build section is builds list, shows your completed and ongoing build logs, dependencies and traces and more. And Docker Scout is a tool that helps manage and secure Docker images. And here is the extension. When we creating the Docker file, we want the extension, we can add extension from here. Here it is. Now it's time to dive into the practical side of the things. My team member is all set to demonstrate how container technologies work in action. They're ready to witness the power of container as they bring theory to life. This is going to be exciting.
Hello everyone. Today I'm here to demonstrate the Docker in action. As my team member discussed earlier, that the Docker is a container technology that provides an isolated environment to run a Docker image. So basically, a Docker image is a template of project that you want to upload on Docker for testing whether it is running accurately or not. So before going to practical demonstration, I want to aware about the Docker image, as there are some sort of rules that whenever an image is created and if we want to update the image, it means if we want to update the code, so we need to create a new Docker image, because there is a rule for updating the Docker file. So let's dive into the practical part. As you can see that the interface of Docker, we can see that there is a container and image tab in sidebar. So basically, if we want to upload the project in the Docker, we need to have an image of it, the base image of it. So actually, there are two types of images, as the user-defined images or base images, which we have to pull from the Docker Hub. So the base images which is needed to run the Docker image and another is created by user. So before going to our editor, we need to check that how to run an image. So here I pull some base images from Docker Hub and run it within Docker as it requires. Uh, okay, so now uh, we as you can see that I already pull some images like Ubuntu and Node. So we simply we simply go to the terminal and run the particular image. We can also run this image from here as actions and run, but uh, we need to run the image from terminal as by giving the command on the terminal as a docker run -it, and here we need to open the base image as Ubuntu. So here we successfully entered on the Docker Ubuntu container. So now we need to update our advanced packaging tool, which is known aka as APT. So we simply give the command to the terminal as apt update. As you can see in this terminal that our packaging tool is updating one by one. So here you can see that it has been successfully updated. So now in Ubuntu Ubuntu image, we need to install a nano text editor as apt as by giving the command apt install nano. It is showing that the reading package list. Here you can see that that our nano text editor is successfully installed. So here we simply click on we simply create a text file on our nano text editor. And so for creating it, we need to give a command to the terminal as nano and the file name as test.txt. It will redirect to the text editor, and here we need to give the content to our text editor as hello world. So now, after giving the content to our text editor, we need to take exit from the text editor. So we simply click the Control X from the keyboard, and we need to it is showing that the save modified buffer. For yes, we need to click Y, and then it is asking for the file name to write as test.txt. We need to give test.txt um, as the file name. So we simply click on enter and it is redirected to our terminal. Then now we want to read our text file uh, which we have created on a nano text editor. So simply give the command as cat test.txt, and it is displaying the result as hello world. So now for getting the getting to take now for taking the exit from our container, so we need to give the command as exit, and here it is redirected to our terminal. So here you can see that I already pull a node image, node base image. So we also get get into it as docker run -it and node bin bash, and here you can see that it is successfully, and that we have successfully entered on the node image. So now we write the command as node sim / version. It is displaying the version of Node.js, as I don't have installed Node.js in my operating system, but I have pulled the image as Node. So so now uh, we need to create a user-defined image. So we need to, as I want to push this project to the Docker. So we need to pull the Nginx image for HTML. So we simply click on pull. So as it requires some time to pull the image, it mean in the meantime we'll start the terminal. So here you can see we have successfully pulled the image as Nginx, because Nginx is needed for creating the for pushing this project to the Docker Hub. So here you can see that this is the base image, or for Nginx, and latest is the tag. We need to copy the file which we want to upload on the Docker as index.html images folder, and this is the command for running the particular file. So for creating the image in the Docker, we need to open our terminal in the VS Code, and by giving the command as docker build -t homepage VIP. Homepage VIP is a class name or image name. We simply enter on it, as it is creating the image in the Docker. So you can check if that we have successfully created a user build image. So we simply click on it, as it's showing a dialog box that we have to set the container name. Container name is landing page. We need to give the host port. So we have give the host port as 8080, or we can also give our host port as 0 by giving the random generated host ports, as we simply click on run, as it is showing that we have successfully uploaded the code on the Docker by going to the logs file, and by clicking on the 32768 link, as 32768 is the random port which is generated by Docker. So on browser, when we write as localhost 32768, It is showing that we have successfully uploaded our project in the container. And if we want to stop the container, so we simply click on it, and we need to restart our tab, and that is just showing that localhost refused to connect. So before we conclude, I'm pleased to announce that our respected director, Mr. Sushil Podke sir, will now address your queries and questions. Please feel free to ask any doubts and share thoughts about how container technology can be implemented in your scenarios. Over to you, sir.
Hey, thank you, Team Axiom. This is awesome. As to summarize the the agenda and the motive about this live session, we're discussing about container technologies. As we as we know, as while dealing with the cloud projects, we need to merge the project. You have to pull the various codes from the various developer, distribute it, and then merge, yeah, using Git, and resolve the conflicts if any, and then redirect it to the specific branch, and through the CI/CD pipelines, we can able to deploy that code to the development, testing, or normally production server, from where we can test that all the outcome or the end result of the application. So it's a challenging part every time to do this. Obviously, this is a final step of the deployment. Instead, if you want to test an entire application locally as a developer or whichever the part you are performing, then container is the best way to do it. We were performing this by creating the various virtual machines earlier, but virtual machine requires different operating systems. So instead of that, by using container, it's a lightweight. It is having it takes a seconds to boot. Isolation is on the process level. It's a shared host. OS requirements a shared host OS kernel, and the performance is very high. So by using container technologies, we can develop the simulation of the entire application locally, and then once we achieve the objective, then probably we can merge the code, we can push through the CI/CD pipeline to deployment server. Various popular container technologies are Docker, Kubernetes, Podman, OpenShift. Today we try to and uh, able to perform that all the objectives about this container technology using Docker. Hope this session will give us all the guidelines regarding why container and how container technologies can be used. If you are attending these live sessions, do comment on the comment section so that we can able to answer you. If you want to be a part of such kind of exciting technical topics, do write us or contact us and do part of this kind of events, so that together we can explore all the topics, share the experiences, and help us explore the topics in such a way that and develop the hands-on, so that we all can able to serve the industry better. I wish you all the best in this last day of a year, and hope upcoming year will make us and guide us and provide us the various opportunities as a career, and we all will be achieve the best in the career as well, professional career as well. Thank you very much for attending session. Hope this session is session will help you out to boost your career, boost your confidence in the technologies. So in advance, wish you Happy New Year. Thank you.